This is the Amp Hour Podcast, recorded May 6th, 2012. Episode 94, Gnomic, Gazumping, Gobemouche.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
What's up, Chris?
What's up, Dave?
That was a very American, what's up?
Oh, yeah. Good day,
Not
mate.
really. Good day. Should we start by talking about who we've got on next week's show?
Next week, yes. We could start with that.
We have got Oyvind.
Oyvind. We hope we're saying that right.
We do hope we're saying it because it's got funny characters in it.
Yes.
You know, those
I don't even know what that is. It's
non-ASCII. I don't even know what the character's called.
Yeah.
But apparently it's a very common first name in Norway.
Right.
And we have Oyvind. He's the co-founder and CTO of Energy Micro on the show next week. So please get your questions in.
Yeah, we'll have a separate post on the website, so if you want to pop over there and drop a question, we will try our best to get that in front of Oyvind.
Yes.
And should be interesting. They're a fabulous semiconductor company. If you haven't heard of them, Dave has done reviews of the Gecko board. Is that right, Dave?
The Gecko, yes, the Energy Micro Gecko microcontroller.
So kind of we're going to talk to them talk to Oyvind about what's it like to be a fabulous semiconductor company
and a startup one at that.
Yeah, exactly. Yeah.
How much cash does it require, I guess, to know what effort's required?
Yeah. How do you go to TSMC and just say, can I make a chip now? Or whoever they're using, I don't know. So.
Yeah, I don't know.
Yeah.
But it'd be interesting. And he's been in several startups, so he should know about all that sort of stuff.
Yeah,
so please
that'd be great.
Get your questions in. We love having CTOs on.
Yep. Speaking of the future, I will be talking at Maker Faire. I just found out this week. And so if anyone's going to be out there, I'll be giving a talk. It probably won't be that good, but I'll be out there anyways. It's stuff. It's in there.
You've got it all cleared up, right?
It's submitted, but it's not written yet.
So were you invited to give a talk, or did you?
No, I applied. So
right, you applied. Okay, cool.
Yeah, the overarching topic is going to be really boring documentation. I'm challenged myself to see if I can make that somehow.
Interesting. Well, that's a challenge.
Yeah, it will be.
It's an interesting topic, though. Documentation is important.
Well, they must have thought so. So we'll see if I can do any good with that. But that'll be in 2 weeks.
It can make or break a company. Like Adafruit, for example, have made their rep on their personal service and the quality of their project documentation and stuff like that.
That's a great point.
So there are.
We could just spend the rest of the show just to help me write my speech if you want.
That's it.
No one has to go. It makes it a lot easier. I can just sit on stage drinking beer, and
right.
You guys heard this already, so
you can just press play and
yeah, exactly. Yeah. And here's me and Dave presenting on documentation. Hope you enjoy.
So how does that work? Is there like an auditorium there where they give speech, where there's presentations all day? I know they have the fair with the stands and everything.
Yeah,
but how do
there's stages.
A stage. Oh, right.
Yeah.
Plural.
So there's a whole bunch of those, and
right,
I'm not sure where I'm going to be.
Okay.
I'm very light on details right now, but
right.
Apparently I will be there, and
awesome.
I know I was going out there, but I'm getting excited about it. So.
Excellent.
I'll be hanging out with Mighty Ohm. Me and Jeff will be hanging out.
Yep.
So, it's gonna be great.
I'd love to do so. I'm jealous. I'd love to do
you
something like that.
Over, man. You know you could.
Oh yeah, right.
Maybe next year. I think
maybe.
That might be the final time when me and Dave finally shake hands and start arguing with each other.
And the world implodes. Yeah.
Yeah.
Oh boy. Well, that sounds like fun.
Yeah,
Enjoy
it should be.
Yeah.
It should be.
Are you going to record it? Are you going to have a video set up?
Oh, probably. I guess so.
Please do.
I think they might do
it to
stuff.
Your YouTube channel.
Yeah. Yeah, I'll try to.
Yeah.
But I got the usual. I'm actually sticking around. I'm going to be there early. I'll go to the Computer History Museum finally.
Awesome.
Surplus shopping,
But isn't Jim Williams' thing closed by then?
Yeah, that's going to be. I think that's going back to LT. But
Bummer.
there's a lot of other cool stuff there. So
Right. Cool.
very much looking forward to it. What about last week? We mentioned the incubator last week. I didn't really hear from anyone, but we should mention that again real quick. The Lemnos Labs. So if people didn't hear last week, I think there's 1 week left on the submission. Lemnos Labs is doing a hardware accelerator program. So if you got an idea for a company, you want to go get some funding, get some support, be kind of grouped in with other people, that's, the kind of the whole accelerator idea, or the incubator rather. Yeah.
It's all the rage, isn't it?
Hardware
doing
is,
your own startup, not only hardware, but software, doing your own startup and these incubator programs and these, it's like every man and his dog. I personally know like 3 or 4 people doing,
really?
That have, joined a startup, quit their job, whatever, and they're having a go at it. It's just, and that's just here in Australia. So
that's a heck of an undertaking. So I'm always impressed with people who can do that. I mean,
yeah, same here. Because it is a lot of risk because most of them fail. If you just look at the odds, you wouldn't do it. Because if you just look at sheer statistics.
Yeah, I think it's a calculated risk in a lot of people because I think a lot of people look at it and say, well, it's 6 months or however long. It's a good idea to set that and say, I've got 6 months. And the nice thing about engineering, at least, I mean, if you were like if you were writing plays or whatever and you wanted to go say, all right, I'm going to quit my copy editing job and go try and write a play for 6 months.
Right.
That's a tough market to get back into, I'm sure. With engineering, I mean, if you're in a decent job market, and I think right now the job market is pretty decent. Maybe I'm wrong. I mean, at least in my area.
It's not bad. It's certainly been a lot worse, that's for sure. So
right, especially the past couple of years. And so there's a lot less risk in that regard. 6 months is still a big chunk of income to take out of your pocket, but if you've saved up and you're willing to take that risk, the upside could be really awesome, and you can meet a lot of cool people.
Yeah.
And I mean,
and if you're going to waste someone else's money, all the better, right?
Well,
if you're spending someone else's coin.
Yeah, I mean, well, you never seemed like you were a big fan of taking money, though, venture funding.
No, I am
anything.
not a big fan of taking money. I'm a big fan of doing it on your own.
Right.
But then again, I'm a big fan of bootstrapping. I think doing it on your own and putting all your money on the line, is just dumb. Right? I think that's just very foolish. Very foolish indeed.
Yeah.
Yeah. Whereas, especially in hardware, like, and software, like, all you need, like software, all you need is time, right? Time and talent, the 2 T's. You don't need money, really. Well, you have to eat, right? But that's about it. And hardware, unless you're doing something massively expensive, you're only talking thousands. You aren't talking, tens of thousands or hundreds of thousands of dollars.
Right.
So, it's not a huge risk. And it's certainly possible to save up the money to do something like that. It's possible to work for, 3 or 4 years, if you're out of college or something, work for 3 or 4 years and then save up the money. You can easily save up, I don't know, 50 grand or something. That'll keep you going for a year or whatever,
Dave's on the ramen diet, yeah.
Right.
Yeah, no, that's an important time, though, and I think a lot of people use that time because, it's a low cost of living. You're used to that. If you're in college, you're used to that, low cost of living, and you can, you go from making nothing to making 50 grand or whatever people are making these days.
Yep.
Yeah, if you're usually spending 20 grand a year because you're a college student, yeah, why not? Save that other 30 grand and use it for something cool, or even, if you're into buying houses or whatever else you want to do with it, but...
Save up that screw you money,
The screw you money. There you go.
Yeah.
Right.
Screw you. I'm going to take 6 months off and work on my startup,
Right.
And, but as I said, the best, as we've talked about before, the best ones, or the best and the safest ones, you start up in your garage and you work on it part-time, and then once you know it's going somewhere, then you quit your job and it's a bit foolish to sort of have an idea and then just quit your job and go, right, I'm going to work on my idea. And and you haven't actually done any background stuff to see if it's A, viable, and, and B, you actually like doing it and it's going in the right direction. And
yeah, a good example of that, I saw that the Evil Mad Science Labs folks, Lenore and Wendell, they just made the plunge themselves. So
oh, okay.
I don't know if they listen, but congrats to them. It's it's like they're doing kit business stuff, and
I thought they were already full time at that.
I had thought so too, but no, they...
Okay. No, they were doing it part-time from the garage?
Yep. Oh, they have a shop, but yeah.
Oh, right. Yeah. Okay. Yeah.
Yeah, it's cool. That's got to be exciting, you know? So I hope to do that myself someday.
Yep.
We'll see.
I can highly recommend it. And please support people who do stuff like this, because that could be you one day.
Exactly.
So if you support them, then they'll support you when you go into your venture, and, you know, it's one big happy community.
Look at that, Dave. Dave, the old softy. I like it.
Right.
Getting soft in his old age.
I am indeed. Oh, boy.
Well, speaking of spreading the love, we have a ad hoc workbench of the week. We haven't done that in God knows how long.
True.
But our buddy Alan, he did a lab tour in a very different kind of
Alan
manner.
From Tektronix, not Alan
Sorry,
Yates
yes, sorry.
Who we've had on the show.
Alan Wolk, from Tektronix, or Alan at Tech on Twitter. But he did a cool video, and he's got a great YouTube channel as well. He does a lot of scope stuff and a lot of fun stuff like that. And he did his tour of his shop through the screen of his old Tech scope.
I know, it's great.
Yeah, so he set up a circuit to do horizontal and vertical sync, and then basically he put the audio or the video out from his camera, you know, just a regular video out, and then he synced it up with this circuit, and then he actually was able to display the video on the screen,
using the
phosphorescent.
Z-axis input for the modulation, for the intensity modulation, which not all scopes have. Not all scopes have a Z-axis input.
Right.
So there you go.
Yeah, it was really cool. I mean, and then he kind of walked around the shop, and you get to see all his gear, and obviously he's a collector of old tech stuff, which is fun.
Yep.
And
he did constant current sources using transistors, and, you know, it was really quite a elegant, simple circuit.
Yeah.
But he did use an off-the-shelf, like a national semiconductor sync circuit, which are I think they're getting harder to get these days. Might these things be dying out because nothing's composite video anymore?
They're all moving to HDMI or even just DVI stuff, right? So it's tougher to find. So.
I like it, but that was good. It's not a new concept. People have been displaying video on their scopes for donkey's years, but it's always fun to see. I love to watch it.
And showing a lab tour is just as cool.
And showing a lab tour.
Too. So,
yeah,
that's great.
Well done, Alan.
All right,
wish I'd thought of it.
Well, next time, buddy.
Yeah. I'm not even sure if my Tektronix 2225 has a Z-axis input. I can't remember.
Yeah, I don't remember what model he was using.
It was a Tech 485. It was an old 485, I believe. Yep.
Okay.
The old workhorse.
Yeah, I've got a 425 that's kind of sitting on my bench. It's not doing much, but...
Is that a valve one?
Is that a what?
A valve one.
Oh, no. No, it's solid state.
No, it's a solid state. Okay.
Yeah, it's the military model, though. So I was gifted it, and I haven't really played with it much, but...
Cool.
Yep, it's fun. I like it.
Speaking of playing with stuff.
Old boards. Yep.
Yeah.
Yeah, what's up?
I finally got my freaking MakerBot working.
You did? Oh, my. How many months has that been?
I know, a long time. And yes, people will say, I told you so, and I never got around to checking it because you had to take the damn thing apart. But it was the problem. The main problem was the motor current. I didn't set it up correctly. I didn't follow the instructions. Turns out I had a different brand of motor, which requires 3 times the current of the MakerBot brand motor. And...
did you buy it separately, or did it get kitted that way?
Actually, no. That's how the kit came. But apparently, there's different types of kits or something. I don't know. So there's 2 instructions.
The importance of documentation, right there, right?
Yes, exactly. And it was there. Granted, I should have checked. I should have read it. Yeah, it was there. When you go back, it was obvious.
Yeah.
But the thing is, it worked. Right? It almost worked at 1/3 of the current. Like, give me a break, right? If it didn't work at all...
That's the worst for troubleshooting, right? When you have, like, an indicator. You expect, like, a very discreet on or off kind of behavior. On or off,
fail, or work or fail, right?
Right,
and that's
those
what
marginal cases is terrible. It's terrible for finding stuff like that.
Yep, I know. So, Murphy's Law, every time, get you.
Oh, yeah. Oh, yeah.
So, I thought I had a working MakerBot because the motor moved around and everything, it made the right noises and it squirted out the stuff and, winner. And, and everyone was throwing all sorts of things at me. Oh, you've got to print directly from the SD card because it can't stream from the USB. It loses the buffer sync and, buffer underruns and screw things up. And and other people said, oh, your temperatures are all out and all this sort of shit. All your belts are all slipping and your, different alignments and it was so everyone's throwing all this info at me, Yeah,
I was going to say, did you go through your usual troubleshooting? Thou shalt check the power supplies and all that other stuff.
Check the power supplies. Well, I checked the voltages for the motor drive currents. And they were as per the instructions. I just happened to be using the wrong instructions.
Aha, okay.
So I did, thou shalt check voltages. Yes, I did.
Yeah.
And it all looked good. And it all almost worked, So I thought, okay, so it made sense that, there could be like a little slippage on the belt or something like that. So that made perfect sense.
Right. That's the problem with troubleshooting. You get in these modes and you kind of, your brain constructs, it could be this. You hear something, you get the seed of an idea and you're like, what if it's this, and this? And you go down this whole path and then finally you get to the end, you're like, oh, no, that's not it at all.
No, it was the bleeding obvious. I should have gone back and,
Oh, that's
with
rough,
hindsight. Man. I know, it sucks.
Well,
anyway,
it works now. That's good.
It works, and it prints. And the first thing I tried to print was a little camera adapter for my stereo microscope, right? So I can put a video camera over the thing. So I measured it all up with my calipers. I put it into the 3D CAD software, and I generated the model. And it was very simple. It was just like a two-stepped cylinder, with two different internal outer diameters. There were no overhangs or anything. Real dead easy to print. And I finally got the thing to print, and it printed perfectly, except it won't print without the raft on the bottom, which it lays down, it lays down a strip of plastic first and then builds on top of that. And you can't separate the bloody thing. It's impossible. And everyone says, don't use a raft. And, well, I don't use a raft and it doesn't work. And now everyone's saying, no, that's because you haven't cleaned your Kapton tape before you started. Well, okay, learned something new again. Right, there's all these little tricks to getting these 3D bloody printers working. Right,
so if you were flying in the dark where you didn't have like a forum or Twitter or anything like that, would
trial
what would
and
happen?
error, you know, forever. Yeah,
it would just sit there basically.
I sit there and scratch your head and go up 10 different blind alleys before you'd eventually crack it. You'd eventually crack it, I guess, but.
Because it reminds me, like, how you said you grew up doing electronics like that, where you didn't have... I guess you had, like, manuals and stuff like that, but was it the same...
You only had the books in your library. That was it. You didn't have anyone to talk to. I didn't have any friends who did electronics. I didn't know anyone who did electronics. And before I started work, I didn't, have anyone... Yeah, I was completely on my own. I had my books and my parts and my multimeter, and that was it.
So does that mean you, like, were ripping stuff up more often? Because, like, usually... When I'm doing a circuit, like say I'm just like breadboarding something, I'll put down parts and whatever, and I'll try this and that. Was it more of a screw this and you rip everything out and you start over? Or was that more of the MO of working like that, where you didn't have any troubleshooting?
Sometimes you did that, but often you'd just try and brute force it, and you'd keep tweaking things.
Switch out this part.
Yeah, you switch out this part until you figure out what the hell's happening, and you build up a broad picture of what's wrong or whatever, and why your circuit didn't work. And and
there's value in that too, because that's I think about like labs that I've been in, and just even doing stuff at home, and that's when you really learn it, right? You
really learn.
You have to, because you can't just be like, oh, well, I'll just tweak this value. It's like, no, I need to know what this value does first. And
there were no simulators back then, right? Or there were, but geez,
Yeah, you didn't have access
I didn't even have a computer until, late in the game, let alone a simulator. So, you build up and trial and error and lots of smoke and fire and lots of circuits which just do nothing, and you scratch your head and...
Yeah.
And you do learn a lot when you start substituting components and troubleshooting. And as I said, I hope your next project doesn't work.
Yep.
And you have to troubleshoot the thing.
Yeah.
Because if it works, like if that MakerBot worked first go, I wouldn't have learnt much, right?
Right.
But now I've learnt about motor drive currents for them, belt slippage, backlash. I've learned about, printing from SD cards is better, cleaning your Kapton tape and doing this and setting this. And, I Unbelievable.
So if you just ordered an off the shelf working printer like the other ones that are out there, you think what happens then?
I wouldn't have appreciated it as much. I guess I wouldn't have appreciated the workings of it. But I guess maybe I wouldn't have cared if these products just worked. If these 3D print, if you could buy a $1,000 3D printer that just worked, then
I wonder about that. Because there is value in it, but at the same time, you hate that frustrating feeling that you almost have to be primed for. You have to be like, all right, I know this is going to be frustrating, and
it's
I know,
not going to work.
Right, exactly. And I'm using this to learn, and there's a lot of value in that. But sometimes you also just want that other one right next to it. And you're like, no, I'm just going to do this, right?
Yeah, I do this because I want my case or my front panel or my widget that I'm printing. I just want it now, and I want it perfect. And anyway, my microscope adapter, I printed it, came out very nice, except the raft stuck to the bottom, but it was nice and round, and, I didn't think it could, do a better result than that. I was quite impressed. And I go to put it on my microscope and my camera, and doesn't fit.
Yeah.
It's...
measure twice,
no, I
once.
measured perfectly, and I even allowed I thought, 1 millimetre might be a bit much. I allowed 0.5 millimetre bigger, so if I wanted a 42 millimetre diameter in a hole, I made it 42.5 in my software, right?
Yeah.
So I catered for that, knowing that, it might turn out a bit smaller, but it turns out like 2 millimetres smaller than what... So if I program in 42 millimetres into my CAD software, I print the thing and measure it, and it's 40 millimetres inside diameter.
Jeez.
And it's like, that's significant. That's very significant.
That's a pretty big calibration constant in there.
Yeah. And why can't that be in the CAD software? Like, how much expansion do you want? Or it should automatically know and add that fudge factor in. Like, I shouldn't be tweaking. I shouldn't have to know that and then tweak my CAD drawing to do that. It should be the other way around. I should do the CAD drawing exactly the dimensions I want and then be able to print, and the printer should know that, okay, it's going to ooze out, the plastic's going to ooze out a bit, and, circles are going to be a smaller diameter than what you've programmed in. So maybe it is in there and I'm missing it. I'm missing the option, but I can't see it, so I don't know. And is that unique to the MakerBot, or does that happen on other low-cost 3D printers? I'm sure the really high-end, your $10,000, $20,000 ones don't do that. I'm sure they're very precise.
I've used them, and no, they don't.
Yep.
No. Yeah,
and then you get into things like overhangs and stuff like that. You are limited to what you can print with these things, as opposed to the big commercial ones. They're much better because they'll print with different materials, and then you drop them in water, and they'll do all the stuff that holds it up will dissolve away, and And, very nice.
Yeah, that's awesome. I love that.
Yeah. But these low-end ones, you're quite limited.
Hey, man, you're using a CPLD where you need, like, a Vertex 6 FPGA,
Right.
And that's what you're asking for, and there's the same thing happening in electronics, too, sometimes you're just going to, if you're using a 12-bit ADD, right, when you need a 20-bit one, it's like, well, what do you expect, right?
Yeah, well, exactly. But
sometimes you don't know you need that, right? You don't know what you need until you actually start using it, right?
And that's the thing. I thought this thing would be able to more useful than what it currently is, and you start using them and you figure out the limitations, and, well, these low-end ones, I don't think they're all they're cracked up to be. They're useful, if you just want to do a flat front panel or something like that, nice, there's no reason why it can't do that. Just watch out your hole diameters, huh? You try and shove your pots in your front panel and you find they don't bloody fit.
Yeah.
And geez, you may as well got out and
the knife
a plate and drilled it yourself,
Right.
I don't know. Anyway, 3D printers, they need to get a lot better at this lower price point, and I'm sure they will, but what's involved in actually getting, good rock solid performance into $1,000 printer? Is it even possible to get that, or are there physical limits to how cheap you can make all of the precision gears and things like that?
Right. Well, I don't know. I don't have one.
I hope not. I really hope. Please, if you've got like a cheap low end. A different brand, a 3D printer that actually works, then please let us know.
Speaking of low end printers, there was a thing on Hackaday a while back, and it was on home. It was using an old Epson printer apparently because they use.
Yep.
I think we've maybe talked about that on here before or something else, but this was like really slick because he actually used like the sheet feeder as like feeding this entire sheet of copper clad PCB
Yep.
into this thing. He prints the resist on there, and I was
Yep.
thinking between that and like maybe a timer and agitator, right, where you're using like a chemical bath, you could do a pretty decent home job. But I'm not sure. Like you could make a decent board at home, but I'm not sure. It might be the same thing where you might just run into it and say, oh, you get all set up, you get all the way through it, and you're like, this is just okay.
I've been there. I've done that. I've tried to make. I used to make all my boards at home, or most of them.
Yeah.
And there's lots of limitations. Often I will have to change my design knowing that I'm going to home make this thing because I can't do the plated through vias, right?
Yeah,
So,
true.
and if those plated through vias are under SMD chips or something like that, right? That's a pain in the ass.
If you're doing SMD chips, you're probably not doing it at home, right?
Oh no, I've done SMD ones at home, no problems. I can get down to 7,000 at home.
Really? Oh,
Yeah,
wow. That's not bad.
I know. It's certainly possible. But and then you'll get over etched or overexposed or something like that. It is tricky.
Yeah, and this isn't with exposure, but yeah, you always did the exposure method where you're actually
the photo exposure. Yep.
Right. Oh, that's interesting too because that's actually what they have to do for chips for when they're doing photolithography. They have to make those same kind of corrections.
Oh, yeah.
Mostly because they've been stuck at the 193 nanometer level. So if people don't know, when you're doing photolithography, there's a certain wavelength of light, and if you don't go any smaller on the wavelength of light, you really start to limit yourself on resolution. Well, they're saying that for years and years and years, and right now I think Intel just pushed a 20 nanometer node.
Yeah,
I'll talk about that in a second, but like they're on 20 nanometers, and I think they finally had to switch over to EUV or 13 nanometer light.
I was going to say, what light are they using to
I think
do
with
that?
20, I think they finally had to do it, but it's they've been stalling it for years and years and years. So there's all these tricks they do. If you actually look at a mask set for a chip, they'll have these really high paid consultants that'll actually and a lot of software too that'll.
I was going to say the software would tweak their software to automatically compensate for that for their process, right?
Right, yeah, and what they do is what ends up happening is, when you're like turning a corner, say you're doing like a trace and you're turning a corner, they'll actually set up these interference patterns so that the interference patterns will actually, when you're finally doing that exposure, it'll actually create the feature you want, it's really crazy.
Nice.
It's like slotted lines and stuff like that, and actually, one of the writers over at Engineer Blogs wrote about it at one point. I think that's how I learned some of it. So I'll try and link that in. But yeah, it's just crazy stuff you'd never think of. But it's all because it's the same thing. It's that same limitations of, in their case, it's the light, and for you, it's if you wanted to do overhangs with 3D printing, or you wanted to try and get some better resolution, you'd have to do fanciness, I'm sure, in the CAD model as well, or same thing with the home PCB etching. You have to do these little tweaks.
Compensate.
Yeah, and really that's a lot of what manufacturing engineering or process engineering can be sometimes, is knowing those tricks and applying them and really taking advantage of these quirks and just trying to eke out that extra 10% or 5% or whatever you need in order to get better.
But in an ideal world, you shouldn't have to. You shouldn't have to tweak your source stuff to match your process. Your source stuff should be exactly what you want, and then your process should be able to do it.
Yeah, that is an ideal world. You are correct, Dave.
And that is what the consumer world expect. So if you want these 3D printers to take off in the consumer world, right? Everyone has, every mum and dad has one to print, little Johnny's toys, right? Then, it needs to be that dumbass.
Yeah, maybe, but maybe that would be a firmore update on one of, like in that case it might be a firmware update, so it's blind to the user.
Yeah, they need to get a bit smarter. Yeah.
Right. Yeah. So that Intel thing I was talking about though, I think we've mentioned on here before. Intel is on 20 nanometers right now, which is an entire process node. So their chips are an entire process node above anyone else.
Yep.
That's unbelievable. I mean, like, the amount of money it costs to do that. So, I mean, like, you were saying, oh, well, it should be in an ideal world. It should be, the process should match reality, right?
Yeah.
And the reason they don't is because of money. That's
exactly. Well, yeah.
because money.
And they're on the bleeding freaking edge, you know?
Well, yeah, and the money allows them to be on the bleeding freaking edge. And yeah, it's just unbelievable because now they're already into FinFETs and all the other crazy 3D based transistors and everything.
Yeah.
And that's how they're even holding off ARM. You know, you wonder, you see ARM everywhere for all these microprocessors. And you're like, well, how is Intel still around? Because the desktop business isn't doing that great. But I think eventually, and I think I've seen this a couple other places too, Intel's eventually just going to be like, well, our technology is great. Our processor is doing okay. We'll keep making those. But, you know, they've already started talking about getting into the foundry business where other people can come in and start printing stuff there.
And they're ideally placed to do that as well because they have the world's best fabs, right? Bar none.
Right. Oh, yeah. Yeah, hearing when I used to be in the semiconductor industry, hearing the vendors talk about Intel there was usually fear in their voice, just because of the demands they made, and you know any big company makes those kind of big demands, and they had to capitulate. But apparently Intel was one of the top.
Nice.
So yeah.
Speaking of printers,
yes,
this is rather interesting. There's a company in Australia I may have mentioned before, Silverbrook. Research. Silverbrook. They're a run by a guy called Kia Silverbrook, who founded it, 15 years ago or something, and he is the world's largest patent holder of useless patents. Yes, he is the world's largest by double. He is like he's got like 4,500 patents, right? And that's his goal in life, is to have the most patents. And he does by by 2 times. That Japanese guy, I forget his name, but anyway, we'll link in a link to Silverbrook. And what happened, right? Mysterious companies have been funding hundreds of millions of dollars into Silverbrook's company, Silverbrook Research, over the last decade or more, and they haven't produced anything to date. They're into, MEMS printer. MEMS, a new revolutionary printing technology that prints out, a page, 10 pages per second or something, at high volume, low cost, and it is marvelous technology.
Like you're talking about like actual paper printing?
Actually, paper printing, yeah.
People are investing millions of dollars in paper printing?
Oh, yes.
Perhaps they should go talk to Kodak. I mean, it's or Xerox.
Well,
they're not doing so hot right now.
Anyway, they do lots of stuff, lots of other stuff as well. And the latest news report, I'll have to link it in. It's actually about 2 or 3 weeks old. I just found it the other day and tweeted it. They have like 300 employees in Australia, so they claim, and 200 of them are PhDs. Over 200, over 70% of their employees are PhDs, right?
Good
so
Lord.
They've sucked up every PhD in the country, literally, right? And they're into, polymers, polymer research and micro machine research and, all sorts of avenues of technology. So they've sucked them all up. But anyway, the interesting story is that there's this guy in the US, and I forget his name because I don't have it in front of me, but he's put in $300 million of his own personal money over the last 10 years into Silverbrook Research. And all this info has just come out. It's just been made public. And he has finally had, he has had jack of it because they haven't produced anything. He's seen no return on his money, and he started to sue them and actually withdrew his money and support. And what happened is Silverbrook had to put all of their employees on a permanent leave or actually sack them all. Depends which report you read. And they're going to form another company to avoid the lawsuit and then rehire everyone.
Oh, jeez.
So, I know, really messy business, right? Really.
That's what you get when you put money in Australia. That's all I'm saying.
Right. Anyway, yeah, I don't blame him. You know, he's seen no return on his investment for 10 plus years. And Silverbrook are famous for not having actually produced anything after all this
God.
time. You know, great place to work. They pay huge money to all these PhDs who wouldn't be able to get any jobs anywhere else, right?
Yeah, it
Where
makes
else
you
can
wonder,
you earn
right?
hundreds of thousands of dollars doing pure research, you know? You can't. So,
Right. Yeah.
and so apparently it's a dream job for them. But yeah,
Right, but you don't have any output.
they have no output. They have finally demoed something at the CES show or something like that, but still, you know.
Right.
And anyway, I just thought it was an interesting story about how, you know, they haven't produced anything. Their backers pulled out and they had to sack everyone and, you know, and, nasty. But...
See, now that's crazy because they've got millions of dollars, right? They're working on this MEMS printing thing. And then I see this thing where this guy takes a laser-scribed DVD drive, right? And he starts printing. He has graphene discs, and he just prints super caps onto them with this commercial printer, right?
Nice.
Yeah. It's just, so if people haven't seen this, it's basically, you know, laser scribe is the thing where you can etch, you know, like if you burn a CD, so you have a writable CD, and then you want to like write the name of it on top, and for some reason you have a Sharpie around or whatever, you want to use this fancy printer. Basically, it's like a laser cutter that basically scribes into the top of the DVD, so you can make this nice looking cover. Well, this guy, he doesn't have millions of dollars. He has this laser scribe thing. He puts a carbon disc on top of a normal CD, and then he actually uses this laser scribe, and that he prints a super cap using that, right?
Awesome.
It's really cool. I'll link the video in, but it's insane. You can get these really precise patterns, and I think that it's to the point where even like, you know, listeners could do this kind of thing at home.
Yeah.
So
because they really are advanced. The optics and the drive systems inside CD writers are incredibly advanced.
Right. And so I guess the larger question is, I mean, do you need the hundreds of millions? I mean, I guess certain things you do need the hundreds of millions for, right? But I guess when they're misplaced like that, good Lord, I mean, that's a crazy story that they're blowing money like that. I mean,
yeah. I guess the only downside to using that is they're based on a spindle system. You know, it has to be something that's been, you know, if it was XY based, imagine the possibilities.
Yeah,
you know,
that's true.
Wow,
you
if
gotta
you
imagine
have
that
this
they could do the
laser
same
head
kind of
on a real precise XY bed, woohoo!
Right,
you know. So that's
it's
neat.
crazy. Yeah, it's really cool.
Anyway, the follow up to the story, the Silverbrook story, which just came out yesterday, was that apparently they might have resolved all the issues. They might have appeased in some way. Secret deals went down, and I don't know. So the employees might be back, but yeah. I don't know. Does anyone else know of a similar story where, you yeah, you do?
Yeah, EE Store. Do you remember those guys?
Oh, right. Yeah, you've talked about them before.
Those guys are full of crap. And I mean, it's the same. It's actually a super cap thing. It kind of ties these two together. It's a company that was in Austin. I was really interested in them when I was living in Austin. I wanted to go work for them because I knew they were hiring process engineers when I was doing that kind of thing.
Yep.
And super secretive. No one knew what was going on. No one. It was a private company.
Yep.
And they said for years, we have this amazing product. It'll be great for electric cars. And they just kept taking people's money, basically. You know, like it's the same kind of thing.
That's exactly the same thing. Yep.
Yeah. I mean, it's the oldest. I mean, and that's that's the problem when you take. You know, like, that's the flip side. You know, like sometimes when you're starting companies, like we talked about at the beginning of the show, sometimes you're gonna be in a tough situation because, you know, like investors are gonna want to dupe you, right?
Yeah.
But I think a lot of other times, you know, companies are out there trying to dupe investors, right?
Investors, yeah, exactly.
That was a lot of concern with that Jobs Act that was in the U.S. where now that Jobs Act passed in the U.S. we talked about on here.
Yep.
You can invest up to like $10,000 into small companies. Up to 1,000 people can do it. So that's $1 million into any company, right? Well, the thing they worried about was people
taking advantage of
snake oil salesmen, right?
Yeah, so exactly.
It's basically selling nothingness and taking people in
and the problem is that could be the average Joe who doesn't know about technology. Right? They could get, sold on, some over Unity bloody energy scam, right? Easily.
Right. I mean, even if you take that, I mean, it could just be a glitz and glam presentation, like really, really slick marketing folk that, like just sell the hell out of something. And, sometimes people just Forget the whole too good to be
Yeah.
true thing. I've been taken in before. That stupid guy flying video.
Right.
I got taken
Oh,
so
boy.
hard. Yeah.
Ah, you gullible.
Yep.
Young and gullible.
Yep.
Oh, boy. So, what does it... what was I going to say? I've got a mental block.
All right.
I'll just go bang my head against the desk here and think about what I was actually going to say, because my mind wanders. It happens.
All right. Well, let's turn the page completely and talk about something totally different. I wanted to call out DigiKey. Have you seen? We've talked about it on here before about how I wanted to have like a thing that was like a visual catalog and like being able to look at connectors and flip through a catalog and being able to see stuff. DigiKey did that. Are they listening, or is that like their new thing? I mean, are they listening?
Be.
I don't think so. But yeah, DigiKey has a new catalog. Like, so, I mean, a lot of people on here are fans of DigiKey, but they have like a graphical based catalog.
Yep.
That's awesome.
So it's like flicking, because that was one of the advantages of a paper catalog, right? You could flick through, and especially if you've got connectors or something like that, you're looking for a particular type.
Right.
And you can't really do that with a name-based search, because you don't really, there's different names and it's hard. But flicking through a visual representation, that's what you want.
Right. Yeah. And so it's awesome. It's
it's handy. Very.
It's not like super advanced yet because it doesn't get all the way down to it, right? I mean, like it doesn't get all the way down to the, and it only has certain things that it's useful for, right? If you're looking for a cap, right, you might know you're looking for like a, an 0805 cap, and then at a certain point you need to actually say, all right, well, I need like a 10 microfarad cap or whatever you need, so. At some point, it does stop and say, "Okay, well, let's get to the parameters now." But I don't think for the stuff where you would need to go visual the whole way, like with a connector, with a cable, or something like that. I don't think it goes all the way to the bottom. But
but it's still very useful.
Yeah, it's a great start.
I really like
and
it.
I hope everybody else copies it because that would be awesome. That would, like I still got a lot of paper catalogs. I don't know if you do, but mostly connector catalogs.
Yeah, I still do. I still have them. Well, not at DigiKey. They've actually stopped printing after my video. They contacted and said, no, we're not going to print the paper catalogue anymore. It's gone.
Oh, yeah?
So, yep.
Well,
so
I meant like these are actually specific vendor catalogs. Like I've got a bunch of connectors, vendors that send me catalogs and stuff. And like for that, I'm like, well, yeah, I mean, I still want it. So, but maybe this is the end of that too. Like it's... I don't know.
Well, that's what I wanted to talk about with the printing thing. Back to it. Have they chosen... Well, no, because it's a similar thing, right? Your like papers go in the way of the dodo, right?
Well, we keep saying that. I mean, it's not.
We keep
it's not
saying
there yet,
that,
but
in general, right? And maybe it's and there's
someday.
right, and there's no money in these things anymore. Like there's no money in making printers, right? It's all in the consumables, right? You can buy a printer for $50. You can buy a laser printer for $50 freaking dollars in Australia, right? It's crazy. Yeah. It's insane, and that almost has to be cost price, right? So there's no money in that. So with Silverbrook making these, this new printing technology, well, has it passed? Is it already past its own prime?
Right?
Like
who would invest in that? Maybe because they started 10 years ago, it sounded good back then. But
yeah, it sounded good back then. But now it's like, well, no, sorry, or the model's changed, the market's changed. That's the same thing with that storage cap, right? The storage cap has that passed. It's has the technology moved on? Other different types of memory. Everyone was working on FRAM and stuff like that, right?
Right.
And
yeah,
it was going to be
MRAM,
VNext, and then Flash came along, and well, their market suddenly just vanished overnight.
No. I don't think with Flash that was a different thing. I mean, I guess Flash kept growing. If that's what you meant, like if they kept getting like higher and higher densities, but.
Well, no, back when they originally started, like the FRAM thing, I don't even think Flash was not around or very immature, and then all of a sudden, bang, they figured out how to mass produce them very cheaply and make them reliable.
Okay.
No, because FRAM started in Australia.
Oh.
It went way back to the 90s, I believe.
Oh, interesting.
Oh, yeah. It's been going a long time. They were working on that for a decade.
Yeah, they're still working on other types of memories, though, too. That's what I thought you meant.
Yeah.
Because, I mean, they have FRAM now, which is...
Yeah, they do have it. There's a niche for it. There's a niche application for it. But it's not also the big ultimate thing that'd be in every consumer device. That ended up being flash and not their technology, not their FRAM technology. But that's what they sold the investors, right? Is that it was going to be in every mobile phone, every computer, and it never happened.
Yeah, and there's probably a lot of people that were really wrong about, like there's a lot of probably, I doubt they were PowerPoint presentations. They're probably transparencies, in the trash bins of the world.
Yeah, overhead projectors,
Right, exactly. And those probably had about the great benefits of FRAM, and they were wrong. I mean, they're just, people are wrong every day.
Well, not necessarily wrong, but they were passed by. With hindsight, they were right. They were right at the time. But they just, it was either harder than they thought, or somebody else came along and actually gazumped them, or another technology came along and gazumped them, or the market changed, like gazump. You don't know what gazump is?
No.
It means get one up on somebody, like to actually beat somebody. You actually come from nowhere and beat them. You outbid them at the last second, or something like that. So.
I imagine like a gazump button on eBay, if you come in at the last minute.
It's like a snipe. That's kind of like a gazumping. Kind of, it comes from the housing market. Technically, it's something different. It means that you've placed a deposit on a property, and they're not supposed to take a deposit from anyone else, but they do, and they gazump you. They
gazump.
Yeah, and there's actually laws against that in certain respects.
Really?
So there's
so somewhere there was a bunch of.
Yeah,
there was a bunch of lawmakers. The gazumping has gone on long enough. No more gazumping. I'm stumping on gazumping.
But that happens. Like, who would have foreseen that printers would practically give them away? Right?
Yeah.
Everyone, I'm sure all the printer makers back in the day thought that they'd be selling $1,000 printers, right? And that's what people would pay.
HP was based. I mean, HP continued their growth path on that, right?
Yeah. And now it's only a niche market where a huge big volume office printers will cost $10,000.
Yeah.
But it just changed. So you've got to be careful of that if you're doing your startup or whatever, and you can get gazumped. You can get passed by. That's why if you spend 5 years working on something, the longer you spend on it. The more chance that somebody's going to come along and beat you, or your market vanishes.
Now, here's something interesting. Speaking of almost not working, I saw an article on, what the heck is this site? CompoundSemiconductor.net. Basically, it's talking about like the doping in an LED. So we've had John Edmond on this show before.
From Cree.
He was awesome. He was the co-founder of Cree. He taught us all about working with silicon carbide, and then the gallium nitride layer on top of that. And basically, gallium nitride and magnesium are the reason that you can have white LEDs these days, right? I mean, there's this whole huge pending revolution, I guess. I mean, I don't know if it's even pending anymore. It's probably...
Well, it's another one. Here's another one where it could get gazumped, right? Some new technology someone's working on might, be 10 times better for 1/10 the price.
Right.
Who knows? Anyway.
People out there, get gazumping. I think we found another ridiculous name to go in our title.
Yes, it might be G. Yep.
Oh yeah, right. Gazump. But basically, this article talks about the blue emissions. I mean, if people don't remember from the show with John Edmond, LEDs are actually the white LEDs we all see. They're all blue LEDs with like filters over the top.
Phosphor coated, yeah.
Right. And basically, this article is talking about how it almost doesn't happen. Like the doping within an LED, and granted, like that's way outside my deal, right? But basically, the doping necessary in an LED is almost not possible. That's what this paper is talking about,
right?
And they're just finding this out now. It says I had the quote in here: magnesium and gallium nitride only accidentally behaves as a shallow acceptor. It's truly lucky that the electrical level lies close enough to the valence band to generate enough holes for p-type conduction. Otherwise, blue LEDs and solid-state lightning would not be possible. Like, that's like one of those things where it's just
what's wrong with that?
There's nothing wrong with that. It's just crazy that like like one tweak in in universal not even universal constants, right? But like it's so on the edge,
Yep.
and now there's an entire industry being based upon it, like
based around this on the edge physical, physics process.
right. And it's not the only thing like this, right? I mean, like
No,
there's
I'm sure there's
other
others.
natural phenomenon that's like this, but it's just when you hear about it, you're like, oh man, it's like when when they're studying about like life starting on the planet Earth, right? And
Yep.
like all the different things that are necessary. Yeah, sure, it happened like that, but it probably shouldn't have, right? You and I
Right.
should not be
Yep,
here
yep.
talking about electronics,
That's right.
It's like all this stuff, and
Some
yeah.
freaky shit happened, and
right, yeah,
here
freaky
we
shit,
are.
right? And so that's what I was. So LEDs are possible because some weirdness. So cool.
I love it.
Yeah, cool article. Definitely, people should check it out and learn more about LEDs because I need to myself.
Oh, that's brilliant. See,
Yeah.
I don't know. I find it fascinating, but I just want to buy them, and so I want them to work.
Yeah,
Yeah,
we've talked about that before.
they're just a
with the-
component.
Yeah,
Like
and
you want to buy relays, and you want them to work.
I do. I've been
Tell us
chasing
about that.
relays. So I've got a project I'm working on where I need like a low impedance path, and I need it not to vary with time or temperature, right?
Yep.
And so I think the first thing people would say, well, you could throw a MOSFET in there, right? You could drive this
Yeah,
MOSFET, and I could, but it's like there's no real guarantees. Either I'd have to like heat it, and then there's self-heating stuff, and basically,
Is it that critical that you need the on resistance to be consistent or something?
Yeah, I really do. It's
Right. Okay.
Yeah.
Right. Yep.
and so it's for a measurement basically, and that's
Right,
why it's in a
okay. Yeah,
measurement
of course.
path. So
Okay.
right there,
it matters. Bingo.
right? Yeah, it would go into my error budget, right? And I mentioned error budgets before,
Yeah.
and
That's a big deal.
right, yeah. So and if it's a big source of uncertainty, more than anything, error is one thing. You can always calibrate out error, but uncertainty, then you just explode in terms of being able to be
And
confident.
drift as well.
Right, exactly. So if you don't know,
Uncertainty and drift are.
yeah.
Yeah.
So those two things, and noise too. I mean, noise is another thing,
Right.
right? But that all kind of adds in there,
And it does. Yeah.
right? So I have this. I need like a really low impedance path, and
It's called a piece of wire.
right, yeah, and
Yeah.
that's
which is
one
like
thing.
a jumper link, right? On off.
Yeah, and that's I've said before, a jumper is just a really really slow relay, right? With
Exactly.
with a meat controller.
Meat controller.
Yeah. Someone said that about I was talking about control systems and
Well,
using
no.
these.
If you wanted to get fancy, you could program in a little robotic arm into your thing, which lifted up the jumper and disconnected.
Yeah. Oh,
But
that's
then that's called a relay, right?
right. Well, yeah, the little robotic arm. That's like
Right.
that's getting into what are those machines called where they're like super complicated, like a mousetrap machine.
a Rube Goldberg machine.
That's it. Yeah, Rube
Yeah.
Goldberg. Yeah. So
Yeah. Right.
a relay
so you need
seems
a
to
relay.
be the best thing, and so I started doing some research just on relays, and what did I need to do? And my thing is I need it to be small. I need it to be cheap, which is that's.
Is it a one-off thing or is it a matrix?
It's a matrix really. So
Right.
yeah, it's many relays, so that's why I need it to be small.
One thing you got to, for those youngsters out there playing along at home, one trap with relays is that if you want to do matrices of relays, and you want to pack them close together, then
Yeah.
they can actually interfere with each other. The magnetic fields can interfere. So you've got to get a magnetically shielded relay. If you
Right.
want to pack them tightly together, if you've got a big card and you're, switching 48 inputs to 16 outputs or something like that
Yeah, so
any
you've had
combination.
experience with that, right?
I
didn't
have
you do that?
indeed. Yeah.
Yeah.
It's a big deal. And you can buy special magnetically shielded ultra miniature relays just for these. They used to go in the phone switching exchanges and stuff like that. You
Oh,
you
yeah.
had to
That was
switch
big money.
10,000 lines to.
Oh,
you know.
yeah.
And these relays cost like $10 a pop in volume. Some of them,
Right.
they're really, they're really high spec relays, and they've got massively low leakage because when you put 1,000 of them in parallel, right, they each might have 2 gigohms, off impedance, right,
Right.
leakage, but you put 1,000 2 gigohm resistors in parallel effectively, and well, that's a lot of leakage.
Right, yeah, it starts to really affect your stuff.
Oh, yeah, and that varies enormously with temperature and time, let me tell you. I've had huge issues with matrices which vary with time, and I had to work on projects where I was actually measuring hundreds of megohms to a gigohm, right? So through these relays. So, wow, it was it was complex shit.
Yeah, getting into high impedance stuff. I mean, that's what I used to do with my old job.
Nasty.
And it's
and
it's
bad enough with
counting electrons.
one or two relays, and you put a dozen, 100 together, and you're in deep shit.
So we should step back in case there's people out there. We forget this sometimes. We should step back and talk about relays just at their base as well. A relay is basically you have a strip of metal and you use a magnetic coil and you physically move that coil or that piece of metal to contact another piece of metal, and that creates a connection. So it is a mechanical process, right? And like Dave was saying, you sometimes need to shield that because stray magnetic fields can then actually make those pieces of metal come together. But it sounds really simple, and yet it really can be crazy. And we've talked about the video on here before where they were making reeds for reed relays. And Dave, you love that video, right?
Oh yeah. Reed relays, if you don't know, are the duck's guts for low signal level stuff.
Right.
So if you're doing low signal level, reed relay is what you want.
Right. And that's another good distinction too. So there's signal level relays, there's power relays. Power relays can be huge. I mean, and
Monsters,
and they're necessary too, because when you're switching power, you can't necessarily unless you have a really fancy, expensive MOSFET or you're willing to burn some power in your device. You need a low impedance path, and often that's shoving two pieces of wire or metal together. In this case,
they have to be sorry.
No, just go ahead.
They have to be a special type because usually they actually have to break huge amounts of current, right? So the arcing is phenomenal. So they have to be special types of metal. They have to be multiple contacts. They've got to separate a certain, a much larger distance than a signal reed relay and things like that. And reed relays have to be, once again, like a gold contact one or something like that. So you get low voltages generated from different types of metal actually contacting. Because these things can end up like a point contact diode if they wear bad enough. Right,
if you get arcing or anything like that, you start to pit there and you change the whole material, basically.
Your relay can turn into a freaking diode.
Right? It's crazy, right?
It can have non-linear effects. It's crazy.
Yeah.
Right? Oh, man.
So, it seems like this really boring topic. And it kind of is. I mean, it is a boring topic, but it's so important because these things are everywhere, right? If you're doing you're trying to hold off a high impedance path or you're trying to create a low impedance path for power, like these things really, really can matter. Yep. So,
and because they're a physical thing that changes, or the rated life of them is a big deal. How do they change over time?
Right. Right.
Wow, it isn't like a MOSFET. A solid-state semiconductor can, be used an infinite amount of times in theory, right? Because there's no wear and tear.
Right. If you don't exceed heat ratings and everything, you should be able to switch it.
They should be
a lot of times.
Effectively. Yeah.
Right. But if you smack two pieces of metal together enough times, you're going to start wearing on it, and
exactly.
If there's any air in there, you can create oxidation, and yada 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 yada.
I'm looking at my alarm sensor up in the corner, right? I've got a house, one of those passive infrared sensors up in the corner, and they've actually got a relay in them, and they've got a very high reliability reed relay rated for 10 million changes, right? Because every time I wave my hand here we go, I'm waving my hand. You can't see it. It's great on radio. And the LED turns on in there. Right, and the relay switches. So every time you're walking around your house, this relay's going off, on, off, on, off, on, right? And it's doing that 24/7.
Right, and if you're running around your house like a maniac, or like Dave's child will be doing in a few months, I'm sure.
Well, little Sagan he loves the red LED comes on, and now he knows that if he waves his hand,
that's awesome.
It comes on. So now he thinks he can control every light everywhere by waving his hand.
Why is that kid waving at the lamp? That's weird. Well, just sit him down, start talking, have him listen to this show. We'll tell him about relays, and this will be.
I need to give him the talk.
Oh yeah, the relay talk. One of many. Sagan, today we're talking about MOSFETs.
Yeah.
We need to talk. Son, step into my office.
Come on.
Yeah. Oh, my goodness.
Boy. But this seemingly innocent topic is,
It's a rabbit hole.
You could write a PhD paper on
Right.
relays, right?
Right. And
Same
so,
thing with anything.
And so, I'm looking for this situation where I need really small, I need it to be low cost, which is, I've already given up hope on that. But I start kind of digging into it. I asked on Twitter. I had some nice responses, so thank you to everyone who helped me out on Twitter. And started poking around. I found one on Mouser, which is this tiny Omron.
Mouser?
How do you say it?
Mouser.
Mouser.
Yeah. Mouser. That kind of sounds Bronx kind of accent, doesn't it? Like,
I say like Schnauzer. Mauser, right. Schnauzer.
Mouser.
Yeah.
Yeah.
And so basically we were poking around on Mouser. And we found one. And so this is actually it was one of those cases where you're on a site and you're looking for a relay, that, right? But you can't necessarily type in low cost and small and get all the things you need. Sometimes there's that one search term. And in this case, it was a very wank term. It was MEMS. It was a MEMS relay. A micro electrical mechanical system, right? That's what MEMS stands for. And so we found one, and it is very tiny. It's an LGA package, right? It's a single. I know, right? It's a single pull, double throw, and it's crazy, and it's exactly what I was thinking about. It's basically I was thinking about it in terms of how a lot of these vendors now are putting coils into their packaging, right? And so to step back from relays, another way you can isolate is with these isolator chips. I know that a bunch of people are doing them now.
Yep.
But they have two chips in there, and then in between they put two coils, and basically it's a transformer. And
it's a transformer inside. They do them for like isolating USB and stuff like that.
Right. And they're actually doing even low power switchers now, like they're DC to DC power switchers, right? And basically it's just two chips in there with these coils, and then it's a bunch of polyamide, like the actual black stuff the chips are made out of. And so I was figuring the same thing. I was like, well, you could put these little coils in there because basically that's what a relay is. You could make very tiny coils, and you could energize those coils, and then you could pull two capacitive plates together and try and actually make contact like that. Like basically just a tiny relay. It's the same idea, tiny relay though. And I'm pretty sure that's what this is. And it's low power. So you don't.
How low power? How much drive current does it need? Because
it only needs...
a good low power read relay will take like 5 milliamps or something like that,
Right. Switching current is... Oh, wait, that's switching current.
A live data sheet readings here, folks.
I know, right? Yeah. I think it's like a 5-volt switch, though. So it's low voltage. But the thing is, it doesn't even matter because this is all an RF relay. And so, of course, it costs like, it's a 10 gigahertz relay. That's what it turns out to be, right? And so it's like, well, all right, I'll see you later. I mean, I'm never using these.
What is it, $100, right?
Yeah, it's like $100 in one quantity. So
yeah,
it's the same thing, and so eventually I came to the conclusion that the balance point of low power and low size and low cost, and it just, I'm asking for too much. And sometimes you hit that point where you're just like, all right, you're asking for too much.
Yep.
But then a couple days later, someone, I think it was Paul on Twitter. He pointed me to a Spectrum article that just came out, IEEE Spectrum, and basically they're now actually doing this at the chip level. And so what they're doing is they create these really. There's this great graphic for it. Basically, though, they create like this. They basically create a relay on a chip, where they create a metallization layer over top of like two contacts, like two metallized type contacts, and then they etch away everything in between. So then it's an air gap, but it's it's suspended by this quote unquote squishy area. And then basically though, there's now a pressure put down upon this thing, and it's actually making a contact. So you'll have to look at the picture. I'm sorry.
I'm looking at the electron microscope photo of this, and it's cool. We'll have to post it in the show notes, I think, because it's just a cool photo.
Right. Yeah. It's definitely a MEMS device. Like this is an ultimate MEMS device. I'm not sure if this is the one I was looking at on the Mouser, but yeah. And but the thing is, certain applications, you just can't get away from needing a relay. And so this is kind of like taking an old technology and pushing it into the 21st century, right?
Into the solid state era, yeah.
Right, exactly. And now, who knows? Maybe this is. I mean, they're still calling it a relay. It's kind of like, well, maybe you guys should call it something else. But just some of the parameters you need to get. Like how do you do it other than actually pushing two pieces of metal together? I don't know.
Well, and the problem here is, right, it is 7.5 square microns, right? That's how big the relay... but you're limited by the freaking package, right?
Right,
to actually mount this thing. The relay... But hey, it could be used... So if you're talking a one-off relay here, it's almost pointless, right? If you're talking, okay, you have one of these MEMS devices in a package. Well, the package is going to be 1,000,000 times bigger than the actual... relay element itself.
Right.
But you could create massive matrices with these things.
Right.
And actually have them on a device.
And that's actually the drive behind this whole thing in the first place. If you actually read further on in the article, that's actually why they're doing this. It's actually it's not for me, and it's not for you, Dave.
Right.
And it's not for anyone needing a single relay, because this thing can't handle any kind of significant power. However, what it can do is what a lot of devices can't do. I mean, we had there's a new TI part out there that's like the successor to the MSP 430. I'm not sure if it's still on our list or not, but it's called the Wolverine, I think.
Right.
And they're talking about 600 microamps of standby current, nanoamps or something like that. And there's all these sleep modes and everything else like that. But the thing is, as you get smaller on your transistors, talking about fabs again, right? As your geometries get smaller and smaller.
Yep.
Physics starts to run. You start to run smack into physics, right?
Oh yeah, runs rampant.
Right, and so basically, as you get smaller and smaller transistors, they need less power to switch on and off. However, the leakage in them, like you were talking about, Dave, it goes way up.
I was going to say, what is the leakage in one of these suckers?
Well, no, that's just in a transistor, right? So CMOS transistor, that's just the basic trade-off. You get smaller, you get less power, but your leakage is way worse. So you have to turn on sleep modes, and you actually shut off whole parts of the circuit with bigger CMOS stuff. You should shut down the power rails basically to different parts on the chip. The idea behind this nano relay thingy is you make everything out of these. It switches way slower, right? So maybe it only can do 100 megahertz, but
only 100 megahertz,
right? Which isn't bad, right? I mean, there's FPGAs running that pretty regularly. But the idea is when it's off, it's totally off, right? It's not like you could just turn off a switch.
Well, no, there's always leakage, and I want to know what it is. Damn it!
Oh well, okay. It's a lot better than a tiny CMOS circuit, right?
Okay.
And that's kind of why they're actually doing this in the first place. And so my journey finding a relay actually found this. It ended up at this really interesting kind of take. It's like this remix of old technology trying to push it into this new era, and it might end up creating. You think about sensors and a lot of the sleep modes and everything they talk about, and even using like energy harvesting and how you can power stuff off vibrational energy
vibration
or thermal energy, something like that. And if you have a circuit that has effectively zero standby current, that could really change some stuff, and it could change how people make chips and everything else. So I thought it was very exciting. I think it's pretty cool.
It is very exciting. I totally agree.
I want to know if these little chips, like if you have a whole array of these things, I mean, you can hear like like an old Pentium processor, you could hear those things clicking away. But if you're actually if you're actually making context now, is that thing going to sound like,
is it going to,
tap dancing?
Is it going to be a high-pitched squeal as you...
Right, yeah. So it's an interesting technology to keep an eye on, I think. So
totally agree. We've gone way over, dude. And we don't even have a special guest.
Oh, really?
But we do next week.
We do. Oh, man.
Ta-da.
We're done?
We're done.
You were right.
An hour and 8 minutes.
Yeah. Oh, man. Okay. Well, I got really excited about relays there for a bit.
As you do.
I do, yeah. All right, so usually we tell people to subscribe to Twitter. This week we were going to do something a little bit different, though. So the most important thing is obviously listening to the show, we think, and hopefully you think so as well. And we realize, though, that sometimes people don't know how to subscribe. Right, yeah, so subscribing is very important. There's links on our website. You can go to iTunes if you're into that sort of thing. But the thing we wanted to bring up, so is subscribing is important. Dave, what's your favorite podcatching program?
I am using Miro, Miro.
Okay,
Miro.
so basically that, and I use Beyond Pod. I use it on my phone because then I can plug it into my car and I listen on the way to work. These are like really easy ways to listen to podcasts. So if you're listening on the site right now, if you just click and play, that's cool because you're probably the ones commenting, which we love. But if it's easier to subscribe, we want to make sure people knew about these other things. So Miro, Beyond Pod, Google Listen, there's a whole bunch of them out there. iTunes, if you're into that whole. Ugh.
And all you've got to do is type in our feed address, which is theamphour.com/feed. Is it?
Well, it's easier to go to our site, but you could use that if you wanted to.
But anyway, you can copy and paste that into your program, and it automatically catches all of our programs, and new ones will pop up as well. And you can choose to play them or download them.
Yeah, and you can set up auto-downloading sometimes as well. So highly recommended.
So it can auto-download to your iPod, to your connected iPod, or it can auto-download to your MP3 player or a USB stick, which then you can play in your car and stuff like that.
Yeah, that's why I like it on my phone, because it just does every night at 2 a.m. I'm getting more podcasts, and so it's awesome. So subscribe. We'd love it if you did. If not, we'll take you listening on the site too, because you're probably commenting. So
awesome.
Looking forward to next week. Oivend.
We are.
Yes.
See you then.
See ya.